Hey Dotcidians, I'm Nick, and today we're going to be talking about superheroes and how physics really doesn't line up with them. And specifically today we're going to be talking about Spider-Man. We're going to talk about the movie in which Tobey Maguire played Spider-Man, and it was the first movie in which a realistic version of the Spider-Man was created. And in the movie, whenever he acquires his powers, he starts doing miraculous things such as shooting webs, jumping over buildings, climbing up walls. But today we're going to be talking about how whenever he jumps over the building, how his initial speed doesn't really line up with what his actual speed should have been. And we're going to have Joey explain most of the situation and how it really doesn't line up.
How did Peter Parker make this miraculous jump of 59 feet in comparison to the world record that's 29 feet? So he jumped more than double the world record distance. Is this possible, and does it defy physics? We'll be discussing that today. So first off, all our numbers are approximations based off of the video itself and how far he appears to have jumped. So he starts right here with a 15-meter run-up over a 2-second time period, where he then jumps up 30 degrees above horizontal and lands what we're calling about 18 meters past where he jumped. When we divide the 15 meters he ran up over the 2 seconds it took him to run up in the video, that gives him an initial horizontal velocity of 7.5 meters per second, which is approximately 17 miles per hour. So he's running pretty fast. All right, that's good. Calculating his y velocity is a little bit more complex. We have to use a right triangle, Pythagorean right triangle, and taking the 30-degree angle into account, we measure his initial x velocity of 7.5 meters per second, and then use the cosine of that angle to figure out that his initial y velocity is going to be about 4.3 meters per second. And then his combined x and y velocity on the hypotenuse is about 8.7 meters per second. This 4.3 meters per second initial velocity in the y direction gives his actual speed that he jumped out with. All right, to prove how this is wrong, we use the parabolic equations from Physics C and use them to prove what his ideal speed should have been if he were to actually make this jump of 59 feet. So we used the delta x equation, simplified it down, and figured out that if he were to jump 18 meters and had a hang time of 2 seconds, which we stated down here we got from the video, his initial x velocity should have been 9 meters per second, which is more than the 7.5 meters per second. Then if we take the delta y equation and simplify that down, we get that his initial y velocity should have actually been 10 meters per second, which is much, much more than the 4.3 meters per second that we said he actually had. So his ideal speeds, you can see, are much greater than what his actual speeds were, so he probably would not have made this jump.
So, just to clear things up a little bit, taking it from the momentum standpoint instead of the parabolic standpoint, we see the equation mv equaling mv. So we took the actual one and took the ideal one and set them equal to each other. So Spider-Man's mass, we approximated based off of Tobey Maguire's weight, was about 68 kilograms. And so whenever we multiply our mass, 68 kilograms, times our actual speed, 8.7, we get 591.6. And then whenever we do 68 times our ideal speed, we get 914.6. So we can see there's an imbalance in momentum. And also, one last thing to consider, this was everything we've done is without air resistance. And if we took air resistance into account, chances are Spider-Man would be dead.